All right. Good morning, everybody. June 9th, we're going to go over these free-form exploratory Excel data analysis projects and then hop into the world of relational database management systems after that. So, Seth, would you mind leading off?
Yes, I can. I've never done this before though. So how do I share the screen?
Down, if you move your mouse on the Zoom screen, and you'll get a bunch of icons that come up like mute and stop camera. In the right in the middle, there's a green button that says share screen. And if you let your mouse sit still, they go away. So it's definitely a motion sensitive. Ah, there you go. Okay, I'll mute my mic and let you take over.
All right. Well, I decided I wanted to look to see if there was well, it's length versus review of New York Times bestsellers, fiction hardback, with data from 2001 to 2022. Let's see. Next. All right. So my question was, is there a correlation between the length of a book and its review score on the New York Times bestseller list? And just as a curiosity, what is the genre breakdown of the 2022 New York Times bestseller list? So for data sources, for the New York, I'm going to get into this a little later. It was actually hard for me to find good, easily accessible data on this. Most of it's split up in a bunch of different places or behind paywalls and things like that. So I used a blog that collected the New York bestsellers from 2022, and then the actual data from New York Times bestseller list. And then for the reviews and the ratings and the page counts and things, I went to Goodreads. So here I've got everything plotted out. So we get review score by pages, right? So I think the longest book on the list was 912 pages, and the shortest was 80. There doesn't seem to be a strong correlation between the length of a book and its page count. I was just sort of wondering, when I was looking at this, do people rate longer books lower or higher? Do they rate shorter books lower or higher? Like some people finish them, some people don't, things like that. That's what I was interested in. Here we can see the breakdown. The majority of these books are mysteries and thrillers, with contemporary fiction making up the next bit, and then science fiction and fantasy after that. Yeah. So my conclusion is that there doesn't seem to be a strong correlation between the length of a book and its review score. And the New York's bestseller list is predominantly mystery thrillers and contemporary fiction, right? So kind of what I learned from this, sourcing data, like I said, it was really hard to find information about these things without having to deal with like an API or something like that. That was kind of beyond the scope of what I wanted to get into with an exercise like this. The data cleaning was also difficult because originally I did find a CSV file of reviews from Goodreads, right? But the amount of cleaning that I would have to do to make it fit for the purposes of this exercise would have taken longer than the entire amount of time I had for this exercise. Some of the books didn't have ratings at all, right? So I would have to exclude those, but there are some books that only have like 1 or 2 ratings, and then other books that have like 40 or 50,000 ratings, right? So I was getting to the point where I was looking at doing like standard deviations to get rid of like the outliers. And at that point, I was like, this is going to take too long. So I just kind of went back and made my own list of things from 2022 to shorten it up. Also, the data that I was originally looking at contained collections. So like if Harry Potter's book 1 through 6 have a different ISBN than just Harry Potter 6, right? And they are reviewed separately on that website. So I would have to try to comb through all of these and clear out all the collections. And I couldn't figure out, there didn't seem to be a marker or a very good way to do that quickly without having to go through and really mess with it for quite a while. The other thing I learned was that genre is subjective, right? I mean, that's pretty obvious, but like their Go Tell the Bees That I'm Gone is categorized as a romance, but it's part of a series of books called the Outlander series that are basically time travel, right? Like a woman travels back to like the 18th century or something like that. And then I think it's romance from there on. But there's a lot of bleed over, I guess, between genres. So that's pretty much what I learned. Um, I think that's everything I've got.
All right. Well, I would say perfect, because you covered everything I was looking for, and it was well within the scope. Okay, Dexter, we'll go again on a future class. Edgar's not here. I don't see Chris, so we'll knock these out again in the future. So no, Seth, that was a good presentation, very clear, and I thought you presented a really applicable real world example of in the data cleansing. You know, your boss may come to you, especially if you're in, you know, kind of a, if your organization is still maturing its analytics, and it's not, you know, a tried and true top tier, you know, analytical effort. It can be pretty easy for a boss to ask a question. Then you go and look at the data, and it's like, oh, good grief. And you find all the kind of things that you said. Seth, you've got stuff that's double counted depending on how you look at it. Like your, you know, your collections versus single books. And just a host of other, you know, not blank values depending on the software that collected the data. It may not make you enter something, in which case you have to decide as the analyst, what are you going to do with those? If there were, since you were looking at ratings, if you got, you know, a blank, you can't assume that because you don't have any ratings that it was a zero. I mean, you're a 1 star or whatever. So there's a lot of judgment calls to be made. And that's one of the good things about like Jupyter Notebook. You can document your assumptions. You can document what you did with the data, and someone else can repeat that, or they can change your assumptions a little bit in the code and rerun it to see what would happen if they made different assumptions than you did. So any questions or comments for Seth? And of course, that was all in Excel, Seth.
Yeah, I did all the calculations in Excel. Basically, I used the blog site because you can't find a collection of every book that appeared on the New York Times bestseller this year just at the New York Times. They have it by like week or month, so you have to find it all put together. So this lady did that on her own blog, and then I used that information to source the other information I needed. So basically, I just went down that whole blog page and then got the information I needed and made an Excel spreadsheet with about 60 or so books in it, 62 different books and ratings and all that.
Were you able to open that with the from web like I was showing Tuesday, or did you have to like drag and cut and paste the table? Seth?
Sorry, I messed something up there. No, I wasn't able to do that because she didn't have it set up like a table. It was more like a bunch of different blog entries, and it looks like she had things like running in widgets that were, she had it like separated out differently. She had it separated on by how long they'd been on the bestseller list. Like that's why I said the data is from 2021 to 2022, right? Even though I was only looking at 2022, because some books, I mean, there's books on there that have been on there for like 40 weeks, so it spans over into 2001, but they're on the list for this year.
There you go. All right, cool. Okay. Alyssa, you ready to go?
Yeah, I can go next.
Okay. Take it away.
Give me 1 second. Sharing screen. Okay, can y'all see the screen okay?
Looks good.
So, sorry, trying to find my mouse. Okay. So I wanted to do movies. So I used Kaggle to find a movie data set. So this data set just had a list of movies and some series. I ended up filtering out the series and cleaning up the data a little bit so that I can only see movies because that's what I was interested in. So generally the data had movie title or movie name. The movie date spanned from 1927 to 2020. The number of votes include the number of people who voted for Metascore, which Metascore is the audience score. There's also, of course, movie revenue in millions. The regular score is going to be the critic score. So that's from a scale of 1 to 10. And the Metascore or audience score is going to be from 1 to 100. Time duration of the movie, director, actors, age restrictions, and description. And that's just generally the data dictionary for this data set. So what I was generally interested in, well, I wanted to do some of the correlation in Excel like you showed on Tuesday. So I was interested to see if there was a correlation between Metascore and score, or basically critic reviews and viewer reviews, if they were any different, if there's a correlation between them. I also wanted to see if there's a correlation between movie revenue and critic score, and movie revenue and audience score. Then I wanted to see just some of the top 10s of directors in movies. I want to see top 10 directors by revenue and by audience score, also top 10 movie titles by revenue and audience score. And are there any similarities, which we're going to look at later. And then one fun question for myself, I just wanted to see what were the top 10 movies by revenue the year that I was born, which was 1998. So this is the first correlation. We're seeing Metascore versus score, which again, Metascore is the audience score and the regular score is just the critic score. The R squared was less than 50%, but it was very close. It looks like a pretty positive correlation, which implies that as the critic score is higher for a movie, so is the audience score, which makes sense. Usually you'll trust a critic. If they say a movie's bad, you're not going to go see it, or you're going to rate it badly too, because you want to think that you have taste. So this, I guess, passed my gut check when it came to the results.
Yeah, that seems intuitive. Can you go back to that for just a sec, Alyssa?
Yeah.
I'm looking at you see how it almost looks like vertical bars of dots. Is that because the values were either they were fairly like 5 or 5.1 or 5.2? Is that?
Yeah.
So it's almost treating it. It's almost making it look like it's not continuous data, even though we know it does. But luckily, there's enough dots that it didn't get confused.
Yeah, it did look a little vertical to me, which I wasn't sure. I tried to clean it up as best I could because it looked much worse than this before. But this was like the best cluster that I could find.
Yeah, I don't think it's any problem with it. We know it's not discrete data.
Yeah.
I mean, not really, but anyway, go ahead.
So the rest of the results are pretty underwhelming, but we're going to look at movie revenue and score. So this had a very non-existent correlation, 1.2% for the R square. We also see that a lot of it is clustered near the left. I wasn't sure if this was because maybe the data was still a bit dirty and needed some more cleaning, but generally speaking, movie revenue and critic score do not really correlate, according to this data set, at least. And then looking at movie revenue and the audience score was pretty similar. There seems to be no real correlation. Maybe just a slight positive like the previous graph showed, but again, not anything significant. So for the top 10s, I ended up using Power BI because I tried using Excel and my Excel crashed. I think because my data set was too large, so I ended up doing Power BI for these graphs. But right here, we're looking at the top 10 directors by revenue. I did this because my boyfriend currently, his favorite director is Christopher Nolan. So he had me watch every Christopher Nolan movie ever. And I just wanted to see, you know, where did he rank? And he was #1, which good news for him. But we also see some other directors that we're all going to maybe recognize: James Cameron, Peter Jackson, Tyler Perry, Quentin Tarantino, Martin Scorsese, and James Gunn. some of these are just the ones that I recognized. But this made sense. You know, these people tend to produce movies that do very, very well at the box office. I think James Cameron, he directed Titanic, which, you know, is a huge hit. Next, moving on to top 10 directors by Metascore. So this is going to be the audience score. This is interesting because I don't believe we have any repeaters from the top 10 directors of revenue. Here we see number one, we have Spike Lee and some others that I don't really recognize myself. But I thought that was interesting that the audience reception related to the movies that those directors produced were not the same as the ones that did very, very well at the box office. And here we're looking at the top 10 movie titles by revenue. So we see Avatar, Titanic, again, James Cameron, Avengers, The Dark Knight, that's Christopher Nolan. So a lot of these top 10 movie titles by revenue, they're directed by the directors that were the top 10 directors by revenue, which makes sense to me.
Any idea why we're looking at French names of some of the movies? Le Monde de
Yeah.
Nemo.
For some reason, the data set has some French names. So this one is actually Nemo, and then there's the one that says La Seigneur is The Lord of the Rings. And that one's Peter Jackson. Then there's the Guardians of the Galaxy. That one's James Gunn, which was one of the directors that we looked at. And then, of course, Forrest Gump is in English. Thank goodness.
Les Gardiens de la Galaxie. Why even have another language if you're just going to put la in front of it and
Yeah.
say it with a Jacques Cousteau accent, you know?
Yeah.
That's interesting. No, but I've seen the
funny.
same thing. And IMDb is a tough database to work with. I've seen it worked with in other tutorials like for Power BI, and yeah, it's full of things that need to be wrangled.
Yeah, I had some cleaning up to do. Unfortunately, I do not know how to fix everything from French to English in Excel, so I just left it how it was. But yeah, I thought it was interesting. And then the next slide, we're going to see that the top 10 movies by audience score are actually all different. So we're seeing a trend here where things tend to do better at the box office, but the audience score might not be as high as other movies. I think some of these might be like more indie, could be foreign films as well. I'm not sure because some things are in French when they're not supposed to be. But yeah, that was just a trend that I saw in when I did directors and movies by revenue and audience score. And then these are the top 10 movies the year I was born by revenue. The first one, again, is in French, but it's Saving Private Ryan. That one beat out everything else pretty much. I'm not familiar with some of the other ones. Again, this was the year I was born, so I wasn't going to the movies at the time, but maybe some of y'all recognize these.
Well, some of them are foreign films that we wouldn't necessarily have seen. That's another issue with IMDb is the I is international. So
yeah, exactly.
Yeah, but Beloved rings a bell. Sans complexes. I'd have to run that into Google Translate.
Yeah, I don't know any of these besides the first one, Saving Private Ryan.
There you
I
go.
guess that's why I did so well that year. Everybody knows about it.
Interesting.
And then some conclusions. We saw that there is possibly a positive correlation between Metascore and score, which indicates that as critic score for a movie goes up, the audience score tends to go up as well. We also see that the top 10 directors by revenue are not necessarily the same top 10 directors by audience score, which indicates that although some directors produce movies that have high numbers at the box office, they're not necessarily fan favorites everywhere because, again, this is international. And we see that the same thing can be said by the top 10 movies by revenue and Metascore, that, again, they produce a lot of money, but the audiences may just like go to watch it one time, like Titanic at the movies, but then they're not watching Titanic all the time. It's like not their favorite movie, I guess, if that makes sense. Mm-hmm. And then lastly, Saving Private Ryan was number one the year that I was born. So that's fun. And this is pretty much all that I have.
All right. Before you stop sharing, whoop, too late.
Oh, I'm sorry.
Before you any questions or comments for Alyssa? That was well done, I thought. Anybody else? Questions on the process or the data? I guess you were that intimidating, Alyssa. I was wondering, to me, and it seemed like you put this up there on one of your charts, and it was counterintuitive. I would think audience score and box office revenue would be very highly correlated. Did you tell me that? Did you examine those two variables?
Yes, I did revenue and critic score and audience score, and they were both pretty low, at least in the R square.
That's counterintuitive, isn't it? Wouldn't you think
Yeah.
that something that everybody loved, whatever, Forrest Gump, whatever, would correlate highly to them having gone to see it, but not, I guess, not necessarily. Maybe folks waited and saw it on video or whatever. They loved it, but they didn't go see it in the theater. I don't know.
Yeah,
I only go see, I only spend money to go to the theater to watch something that is a visual spectacular. I won't spend the money to go to a theater personally to see something that is more of a drama. I'll wait and watch it at home, but I've gone to see, the big, some of the more like I saw it wasn't the best movie, but visually it was striking, was that one with Sandra Bullock, Gravity. I saw that in IMAX, and I wish the story had been as good as the as the graphics were. But anyway, that's just me. Cool. Okay, and no, and you said you had to do some of that in Power BI.
Yeah, I did the top 10 charts in Power BI because I attempted to do them in Excel, and I think the data set may have been a little bit too much when it came to like the directors, because I wanted to do the directors and then filter by top 10. But when I had ran it with all the directors, that there were too many and it crashed. And then I lost some of my progress. I didn't want to redo that. So I just went into Power BI to make those charts.
Okay. Yeah, I'm trying to, I haven't seen the data set necessarily. I'm trying to think of, if you put it in a pivot table and you did a count of revenue or sum of revenue as your value field, and then sorted by director, there's hundreds, thousands of directors in that.
Yeah, there are a lot of rows. I have over 100,000 rows.
And then so many individual values for director. That's the problem with pivot tables. If you're pivoting on hundreds, thousands, it's not anywhere near as effective.
Yeah.
Cool. Okay. All right. What do we got? 9:59. Got time for another one or two. What do you say, Kevin? I think we can knock these out this hour.
Yeah. Let's see. Oh, there we go. Are you able to see what I have?
Looks good.
Okay. So I looked at, well, I guess background is I like to box. So I decided to look at how boxing stance affects your boxing performance at all. And so I got my data off boxrec.com. It's just like a database of every boxer's performance or their records. But my constraints were that it would be only pro boxing and men's boxing, but for all weight classes, both active and inactive boxers, so historical boxers as well. General overview of my analysis that I just looked at win percentages, KO percentages, points per fight, and then from there I did significance testing since it's just two classes instead of, handedness isn't very measurable. So some background: orthodox fighters are right-handed boxers, southpaws are left-handed boxers. Southpaws make up 10% of the world, and so my thought process or my hypothesis was that since there were less southpaws, they would have more experience versus orthodox fighters than orthodox fighters would have experience against southpaws. Does that make sense?
Makes sense to
Um,
me.
so also the points, I guess it's not on this image, but points are given in each round of boxing. Generally, whoever wins a round gets 10 points, and whoever loses gets like 8 or 9 points. That's just to set up like where this point measure comes from. So here's an image of some of the data I collected. This is ranking overall top fighters based on points. So from the website, I got the boxer's name, their points, wins, losses, draws, and KOs, and stance. And so everything past the stance is what I did. So you can't really see from this, but this is points per fight on average per boxer, win percentage, win-loss ratio, and KO percentage, and then if they were an undefeated boxer or not. Interestingly, in the top 50 boxers of all time, 5 of them were southpaws, so that matches up with the 10% of all people are left-handed. So yeah, some basic analysis from the stats. If we're just looking at raw data, then southpaws seem to have better stats, where the top 50 southpaws, 8 of them were undefeated versus orthodox's 3, and the average win percent and KO percentages were higher. And the reason I have points per fight rather than raw points is that, as you can see, since there were a lot more orthodox fighters, there are a lot more total fights. So if we just looked at raw points per category, it wouldn't really account for the fact that orthodox fighters have more fights and more rounds to get more points. Okay, so like I said, instead of doing like regressions, because handedness isn't very measurable, I did significance testing. So first I did it with the win percentages. And even though we see that southpaws are winning more on average, it's not very significant. It's almost significant. If we look at this p-value, are you able to see my pointer?
I can.
Yeah, if we look at this p-value, it's only a 0.07, but I chose an alpha of 0.05, and so since it wasn't beneath that, we failed to reject the null hypothesis, right? So the null hypothesis was that there is no difference between their performance, at least in terms of win percentages. If we look at KO percentages, it's kind of the same, where even though the mean of southpaw KO percentages is higher, the p-value isn't low enough to indicate that there's any significant difference between the two. In fact, less so than the win percentages. And this probably has to do with the variance of these, which, looking at this now, this is a very high variance. I'm not sure if that's correct, but
Super high. Yeah.
Moving on to points per fight. Interestingly, this is where we see some significant difference, and not in the way that I expected. So we see that orthodox fighters have higher points per fight on average, and from the analysis, it's actually orthodox fighters who perform better. There is a significant difference between them, as we see that we have a p-value of 0.008, which is much lower than 0.05. So I'm not really sure how to interpret that, I guess.
Yeah, me neither, Kevin. And that's why I don't do inferential statistics in this course, because I'm not comfortable with it. Because what you've got isn't a sample. These measures of significance are between 2 samples. Like if you went out across America and polled 100 people at seemingly at random, and then went and did it again seemingly at random, or sent 2 different people out, and they literally went and as random as possible, polled 100 people. Those are two samples from the population of America. And there's a way to look at those two samples to see how closely or differently they measured. And that's where you use a lot of these statistical tests and whatnot. And I hang on to that concept, those concepts by my fingertips. Not enough to actually speak authoritatively to them. So I don't even try. But good on you for throwing those tests in there. But I think that's what those tests are, is it's looking at the Southpaw numbers versus the Orthodox numbers as if they were samples from a
Yes.
population.
Yes.
But what you've got is the population. You have all the data for all the fights. I don't even know how you would get into interpreting what are the chances of a random Southpaw, or predicting, you know what I mean, the success of a random Southpaw new to fighting or whatever based on that historical information. But yeah, good on you for throwing that in there. Can you put your slides back up? You did one other thing that looked really cool. I wanted to conditional formatting with a chart there. In your win-loss ratio.
Yes.
So you've got a couple of techniques combined there, right? You did a calculated field.
Mm-hmm.
And then walk us through how you did the bars.
Oh, so it was really just like a raw count, just a visualization of the win-loss ratio. Something I should note, since it's a division, so like with Ray Robinson, we see that there's 174 wins and 19 losses. So this would be 174 over 19. We can't really do that with fighters who haven't had any losses, because you can't divide by 0. So what I did was, this was like a INSO formula where if losses was 0, then just return the wins. But if not, then do win losses. That way we actually have a good set of numbers to look at, or like some of these wouldn't be undefined, right?
Yeah, gotcha. And then the bars.
Yeah, so these bars are just like visualizations of like the raw values of the win-loss ratios. I just went to the conditional formatting and added in bars.
There you go. Yeah. So in conditional formatting, you don't have to do colors. You can also add those bars. We didn't go over conditional formatting during the workshop, but it's or very much, but it's handy technique. Okay, I'm trying to think of how you would do that math if their percentage was 100%. You know, like you said, Floyd Mayweather is undefeated. Win percentage is 100%. That's good enough, right? Because your win-loss ratio with the bars is just the reciprocal of your win percentage. 87.44 plus 9.16. No, that ain't right. I would think your win percentage.
The only
because there's losses and draws and all that. Yeah. Okay, there you go.
And so this is just looking at straight wins and losses, the bars.
There you go. Cool. Comments, anybody?
I didn't know anything about boxing, so that was kind of interesting to see.
There you go. So conventional is right foot front and you jab with your right.
Orthodox would be your left foot forward.
Yeah,
and your left.
And you jab with your left. Yeah.
Yeah, because your right hand would be stronger, so that would be your cross.
Your cross or your uppercut or whatever or you spin it around in the air and then you go bam like Sugar Ray Leonard.
Yeah.
That's my era. I actually saw Sugar Ray and I think it was Thomas Hitman Hearn right before I flew home from Guam. We watched that fight live in the in the middle of the day or morning because it was on live and I was on Guam, so it's 12 12 hours clock difference. It was Sugar Ray and one of them, I'm trying to remember, one of the big whatever they were, middleweights back in the day, like 1987. Anyway, good stuff, man. Okay. Jeanette, you're ready to bat cleanup
Yeah.
here?
Yes, no worries. Let me share my screen. All right, is everyone able to see? I'll go ahead.
Looks good.
Present. No?
It was there.
There we go. See if that. There we go.
Looks good.
So I decided to look at college basketball. What kind of interested me in this is I'm very competitive when March Madness comes around, and I love any tips and stuff I can get to win it all and win the money that I put on bets. But so I decided to look at the data for 2021. The data that I found inside Kaggle actually included 2013 through 2021, but I decided just to look at then that season for 2021, just to make sure that when I'm kind of looking for my question, hang on, sorry, didn't show my question slide. But what I was showing for, I don't know why it's doing that. Here, I'll just show this one right here. But what I kind of wanted to see is if certain things, like a 2-point shot or more 3-point shots, or if you steal more balls from the offense when you're on defense, do those constitute to more wins? And so that's kind of what I went through the data to see. So I decided to look first at the number of wins regarding how many 3-point shots that actually happened. So the percentage for the 3-point shots is taking into account how many 3 points they've attempted, and then the percentage is how many of those actually constituted to 3 points. So unfortunately, I found that there was no correlation, and because the R square was so low at 0.04. So I thought for sure the steal rate would have a correlation, but unfortunately this one did not as well. The steal rate is pretty much when you're playing in defense and offense has the ball, and it's when you successfully gain possession of the basketball. Since 2 points are more common than 3 points, I decided to see if that was something that helped with more wins. This one did have the highest R square, but is still too low for me to say that there is any correlation. So last, I decided to look at offensive rebound rates. So if the offense misses their shot, this is when they gain possession again and try for another shot. I thought for sure this one would have a higher R square. I thought, if you can keep the ball on your side of the court, you can win some more games and create more points, but it showed to me that there was also no correlation. So that led me to my conclusion that there is no part of a basketball game that is more important than others, which I thought was super interesting, which I'll show you in my next slide about extra findings. But I thought it was interesting, but it's also really cool to show that a game like basketball, that's a team-based game, that it is really important to play as a team, and every single element of the game is equally as important. So just some fun kind of findings that I had. So Baylor's highlighted here because they won the basketball championship in 2021. And so I thought it was interesting that they were in the top 5 for steal percentage, 3-point percentage, and then best offensive rebound percentage. So even though there was no correlations, it shows that being good at those things might help you win the championship maybe. And then they actually were not part of the 5 teams with the most wins. And I think that's really interesting because it is so hard to predict March Madness and who's going to win. And so I just wanted to see if there was any insights. And then just something fun, I was really sad that the SEC is not #1 at this, since I'm a huge Hogs fan. but it looks like the Big Ten is actually the leading in the most wins, at least by conference, for the season. So that's just a little bit of what I found looking into the college basketball data. If anyone has questions, just let me know.
Can you put it back on your slide 9
Yeah.
that had all the interestingly enough things? I just wanted to do a couple of preview going forward into Python here in another 4 or 5 weeks. When you've got columns of data and you're you're interested in how they might be correlated, you can do them individually. But Python's got a in one line of code, it'll go through and for every numerical variable, every numerical column that you have in a spreadsheet, it will do a correlation matrix. So in one line of code, you get every variable compared to every other variable. So that you can instantly go in and go, oh, look at that. Nothing, nothing, but that looks interesting. Without having to do them individually. There may be a way to do that in Excel, but I've not found one. But it looks pretty cool in Python. So it's just one of those things about Python I mean, there's a lot of people that authors and the no kidding the big dogs out there won't even use Excel for data analysis as far as published data analysis. I think it's great as an individual tool. So I'll say that. But there was one other point I was trying to make about these ranked listing. Oh, machine learning. When you've got, have you guys heard of machine learning?
Yes.
Okay. I'm going to assume that not all of you are familiar with the 2 major families of machine learning. One is called supervised machine learning, and that's where you have fraud detection, where you have picture a spreadsheet and each row is an individual credit card swipe, and the columns are things like store code, store zip code, store type, vendor type, length of time since the last time you swiped your card, raw distance from the last location you swiped your card, whether or not it's online, whether or not or it's in person, whether or not you typed your PIN in. These are all columns that describe an individual credit card transaction. And then finally, at the end, you've got fraud or not fraud, and that's called the label. And then they feed all of that stuff into a machine learning algorithm so that the system, the machine learning implementation, learns what factors or columns contribute to identifying fraud or not fraud. And then they use thousands or millions of rows of that data to then train the implementation as to what a fraudulent report looks like or doesn't. So that's supervised machine learning, where you tell it fraud or not fraud so that it will learn, and then it will guess and you can test the effectiveness of your training data. You can look for how many times it's falsely wrong, how many times it misidentified something as fraud that was not, or vice versa. But then there's unsupervised machine learning, which is kind of what you're doing in this, where it's the same scenario. You've got columns of data like these basketball teams. You've got their average player age, their average player percentage in free throw, and you've got elements about each team, lots and lots and lots and lots and lots of attributes about every NCAA team. Well, you can feed that into unsupervised machine learning which sometimes is called data mining. And they use, there's algorithms called clustering algorithms that will start to show you what factors contribute to those individual teams being more highly placed. And that sort of data mining or unsupervised machine learning can show you things that you may have not even thought about. It could have something, I mean, as long if you've got an attribute or a column, it'll go in there and start to look at how that affects their success or their ranking or whatever the case may be. So that's getting to be advanced data science, but that's how the no kidding top folks are working at it. Well, okay. Well, this is any questions for Jeanette? After my long-winded spiel about machine learning? Okay, well, let's take a break. And when we come back, we're gonna change topics and move into relational database management systems and all of that stuff. So I got a 1022, 1022, 1032. Let's call it 1037. 1037.
Hey, Don.
Go ahead, Seth.
Hey, do we need to like send you any of this? Like, do we need to?
Yeah, there's an assignment if you'd upload your whatever you put up there.
Okay, so
There's
just the PowerPoint presentation, or do you want the Excel file too?
I'd love to see the Excel file. There's a couple of them I wanted to. I was curious about something. So yeah, if you could upload your Excel and your PowerPoint to the. Seems like it's called data analysis with Excel.
Okay, thanks.
I'll pull it up real quick. Clicking on assignments. Thanks for bringing that up, by the way, Seth. I forgot to clarify that. Yeah, it's called Excel Data Analysis Project. So if you could upload your files to that, I'd appreciate it. All right. See y'all 1037. Welcome back. Great job, guys. Everybody that presented this morning, we'll catch up with the other half of the class as we're able in future weeks. So break. New topic. Going to move into relational database management systems, which just another way of looking at the same kind of data that we've been dealing with in spreadsheets, but laying it out, designing it up front to confront issues that you see in spreadsheets. I've picked up some databases, a couple, not like I've seen this 100 times, but a couple of different times I've gotten involved with a database effort in Access that someone had started in Excel, and they thought like a spreadsheet thinker, which is just a little bit differently than the way you think about data when you design a relational database management system. So I've got a brief primer here on relational database management design. So I will go ahead and share my screen and bring that up. Okay. And I found the perfect presentation on a academic social media site, basically, coming from the Kansas University. Database design, which unbelievably, so there are elements of this that have changed over the years as far as what an RDBMS can do. The functionality has been extended, but the basic tenets of relational database design have not changed since I learned them in 1988. So this is probably the one area of technology that has persisted the longest. So we're going to talk practical database design for relational database management systems, and a little bit of background terminology and things to think about before you even turn on something like Workbench or start creating database objects or anything like that. And it does help if even if all you do is query, it helps to keep this stuff in mind, I think, as you're using SQL to grab data out of tables. Okay. So this is the underlying foundational theory. A relational database management system. Now, even backing up, you know, a database is any collection of information that belongs together. I mean, the good old fashioned, probably haven't seen it except in videos. I don't know if anybody remembers the card catalog system in the library, where things were organized. You could either search by title, by subject, or by author. And that was that, because there's only so many ways to organize those cards, and you can't have redundant. So you had 3 different collections, basically organized in different, but it's the same data, repeated but sorted in 3 different ways. It was crazy, but that's a database. It could be, you know, a recipe box with, you know, the name of the recipe and the ingredients and the instructions for preparing it. That's a database. But of course, it evolved to become, you know, what we think of as a computerized database. But you know, like back in the day, back in the, you know, the 70s, 80s, the formation of information systems, the data, the underlying data of something like a banking application, were in text files, large text files that you would read into a specialized program, you normally written in something like COBOL, and then you would, you the programmer would have to do all the coding to, you know, add new records, to sanity check things, to make sure that it was okay to delete this row out of a text file. And then you'd have to do all this file manipulation and database transaction processing logic, all in a unique custom program. And that was repeated across every industry, I mean, there were very few off-the-shelf solutions. So you had all these programmers doing the same logic over and over and over and over again. And it just didn't make sense because they were all doing similar things, right? So in the late 70s, 80s, by the time I got involved with Oracle in 88, they'd been around close to 10 years. So that was the genesis, and Oracle is still a huge player in the database market today. So what they did was create a piece of software that does a lot of that for the programmer automatically, manages these tables and rows and columns, and manages the language that you use to access that database, all in a standard piece of software. And that's your Oracles and your MySQLs and whatnot of the modern era. So for our purposes, a relational database management system is the software. A relational database is a collection of information, related information in tables, and the tables are associated with each other, and this is what makes it relational. Is they're associated with each other because they have columns in common. You've heard me use the word attribute 100 times, referring to a column like in a spreadsheet. Same way with a relational database that we'll be dealing with. So we got columns are the individual attributes of a record or a row. Generally speaking, we call them a row, rows and tables and rows. or columns and rows. A table is made up of columns and rows, and they're related through common fields known as the primary key, which we'll talk about in just a minute. And in another table, that same attribute is a foreign key because it's a primary key in another table. And we'll work with that just to make sure it's all solid. And it allows us, to find, update, delete data quickly. We can index and all that kind of stuff. So a primary key is the unique identifier for each. It's a column or columns that uniquely identify a row. The value in that column uniquely identifies that row. So think employee ID in an employee table. It's only in there one time. Everybody's got to have an employee ID or the system crashes on you. Or the system prevents you from entering an employee without the employee ID. So primary key fields they have to be unique and can't be null. That's what their use is. You should generally always have a primary key field, always. And you can use a concatenated key, which is two fields that together uniquely identify each row. Generally speaking, there are special uses for those that I'll go into. And then a foreign key is a field in a table that refers to a primary key in another table. Like if you were to have, so I used employee as an example. So you've got one row in the master employee table that has their name, maybe date of birth, that sort of stuff. But say you've got a training table that talks about what training courses you have completed. Well, employee ID will likely be in that because there's going to be a record of you taking a certain course. And we might have to add some other fields to make a concatenated key where like you've got employee ID and the course ID that you took. Maybe put together, concatenated would make a unique identifier. But that employee ID is a foreign key because it's a primary key over in the employee table. So there you go. Primary key, foreign key. Stop me if I'm violating your sensibility or something you've learned before. Okay, so normalization database normalization is a process. So you say that a database is normalized when it follows this process, and that the data has been laid out according to these rules. And I would go through this quite a few times when talking to users. I'd be hearing things as they talk about the data that they're maybe converting something from a spreadsheet, or could be a new process, or a combination of 3 or 4 different processes, and they start telling me about things, and then you start drawing it out, and as you go through this normalization process, you will wind up with tables and columns, and in your format, and then the rows are the actual data. So you don't really do that in your design phase, but that it will start to flesh out that way. So we do normalization to eliminate redundancy, make sure we're putting stuff in the table where it belongs, and a database that is normalized will require the least amount of overall, the least traumatic restructuring of the database when data is added. or even the structure is modified. So there's 5 levels of normal. There's first normal form, second normal form, third normal form, fourth and fifth, and then I think there's one that's even called Boyce Codd normal form. You may have learned about them in theory, but in practice, third normal form gets you where you need to be, and that's all we'll deal with within a typical database, sometimes called a schema. Third normal form gets us there. Okay. For a database to be compliant with first normal form, there's no repeating or duplicate field, so you don't have the same field in there more than one. Every cell contains only one value, and that requirement can be insidious if you look for it. And then each record is unique and it has a primary key. It's identified by a primary key. So there's a lot of stuff you'll see that that violates this. So it's easy it pops out pretty quickly. So in our little teeny tiny example database here, this table is not in first normal form, mainly because the colors of a t-shirt, red and blue, there's 2 values in colors. There's just no way to work with a column that has multiple values. And then there's duplicate records. You've got a t-shirt, red and blue, 12 and taxes of 60 cents, it duplicates. So yeah, this is a mess, and you can see that when you first see it. So that's really, it's, the first normal form is a mess if it doesn't even meet first normal form. But I did want to make a mention of multiple items in a field. Sometimes it's not as straightforward as seeing something as obvious as, this red and blue in the colors. I've worked with databases that had intelligence built into a single field, a single column, so that within that column, the first character of that, say it was a 10-character string, there was all kinds of intelligence embedded in that column. Like the first character stood for what department it came from. The second character was, if it was A through F, it meant this. And if it was 1, 2, or 3, it meant something else. And there was just a lot of meaning in different columns of the same column. And it's just a nightmare. It's just a mess, trying to sort out the rules that are embedded in that are not in the structure of the database. So just watch out for that. So yeah, this is a mess. Second, the way we fix that. Yeah. So we have, we've separated out red and blue, but we still, as far as t-shirts are concerned, but it's now in first normal form, but we can still improve on the design. So all right, so that's how we broke it out. And so now we don't have more than one value in color, and we do have a concatenated key. We've got t-shirt and the color red as a concatenated primary key. So we don't have any duplicates in this table. But yeah, I think we'll all see there's better ways to do it. So second normal form, all non-key fields depend on all components of the primary key. So up here, we've got 2 components of the primary key, right? And you'll see that this violates second normal form because the tax doesn't really depend on t-shirt and color, really. So we'll see down here. All non-key fields depend on all components of the primary key. For example, tax, they depend on the item, but not the color. But even that, you've got the same tax applying to different, anyway. So that's, yeah, That's your second normal form. All non-key fields depend on all components of the primary key. And I'm sure you can tell by looking at this, you're screaming, just you need to have an item number and then item attributes. But yeah, well, this is the textbook first and second and third normal form. So you can, if you haven't seen it before, you can say you've seen it. So what we will see is that when you start to have something like that, it needs to be broken out into separate tables. So we've got the tax for $12 on a t-shirt is 60 cents. I'm sorry, the price for a t-shirt is $12 and the tax on that is 60 cents. So we've got item and color are our primary key in the left-hand table, and item is, in your item table, item is the primary key, t-shirt, polo, and sweatshirt. And it has its unique price. But again, we're going to see here that this tax is not something you would store there. So third normal form, there's no non-key field. It depends on another, which is what we got going on here. We got tax depending on price, and that violates third normal form. So the way we fix that, yeah, these tables are not in third normal form because tax depends on price, not on the t-shirt, not on item. So we will fix that by coming up with a tax table. Now, again, generally you would calculate tax, but it could be that there's a different, you forget price and tax. It could be some other associated calculated field. But yeah, 60 cents on 12, $1.25 on 25. It could mean that things that get more expensive, once they meet a certain threshold, you've got a different tax rate, so that it, but anyway, we fixed it here because tax now depends on price. Price now depends on item, and you've got a master database with a concatenated key of item and color. So they're now in third normal form. But we'll use this process when we start looking at table joins. And just because you see data in a relational database, and just because you can query that data with SQL, doesn't mean it is in third normal form. You see violations of this. Sometimes it's intentional. A lot of times it's a matter of convenience. People are reading unnormalized data into a table just so that they can use SQL to query it, but it ain't right. And depending on the discipline and the age of the system, you see folks just not, beg your pardon. You see folks violating these tenets frequently, even today in 2022. Okay. Any questions on first, second, and third normal form? Or has everybody, give me like a reaction here, a thumbs up or a whatever, a smiley face. Has everybody seen this already?
I've read about it.
I've seen it before.
Seen it in class, read about it. Yeah.
Yeah.
Dexter, did they go over this for you as a SQL analyst? You got some of this in those SQL courses you took from Ed2Go, right? And back in college?
Talking to me, sir?
Yes, Dexter.
Yes, sir. We did some of this back in college, but we had to do ours from the command prompt. Now they doing it in Workbench, but yeah.
Yeah, we'll see that. A picture is worth 1,000 words. And I'd like to see an entity relationship diagram, which is where you start showing the tables and their columns and how they relate to each other. And we'll get to that. But yeah, back when I started all this, it was nothing. It was command prompt. There were no graphical user interfaces into the data like you have nowadays. Makes it a lot more intuitive to look at. Okay, so I think we got a little bit further to go in this presentation. And just make sure I got a text, make sure it's not my wife stranded on the side of the road. Okay. It's my flight. I'm flying out this afternoon, going home to see my mom in Orlando, Florida, and my flight is delayed. Yay. Okay. So another example. Where are we at here? Let me collect my thoughts. We got someone's name, Jeff space Smith. That's never a good idea. Assignment 1, assignment 2. Yeah, this is table's not in first normal form because it's got that assignment 1, assignment 2. What do you do when assignment 3 comes along? You got to modify your whole database. That's a recipe for disaster every time. First and last name are in one field, and you see that, but it's not good. It's not good database design. It violates first normal form, and there's no primary key. You don't have a student number or anything like that. I'm in this assignment 1, assignment 2 hell using my customer relationship management software because I can't create a table in the system to avoid that. So I track invoices that are paying for people's training, and I'll often have 1, 2, 3 invoices up to 5 now. So I have invoice number 1, invoice number 2, invoice number 3, invoice date 1, invoice date 2, invoice date 3, all these columns where it would be really nice if I just had an invoice table that would let me avoid this. But there are people that don't understand relational database design that will design a spreadsheet this way, and it's just ugly. Should make you cringe as an analyst and a relational database management expert. Okay, another example. These tables are in third normal form. We've got an assignment ID, and then everything about that assignment, like its description. Maybe it has an assignment type. You could add columns to this assignment, this top left table. You could add columns to that would describe that assignment. And then you've got a student table with a student ID and then attributes about that unique student. And then you join those two. Now they've highlighted student ID in yellow, but this is an example of what I was talking about of a concatenated key. Now you've got a what we will see is a many-to-many relationships of there are many assignments, there's many students. Well, now we have to figure out a many-to-many relationship to track how each student did on each assignment. And not every student has to have every assignment. Not every assignment has to have even been assigned, but there's got to be a way to track the union of assignments and students. So that's how we come up with a table like the one on the right-hand side. And for that assignment ID and student ID, we will have the grade, the date of completion, any attribute you can think of about the way a particular assignment played out for a particular student or related to a particular student assignment combination. Yeah, there you go. Okay. Relationships are created between tables using the primary key field and a foreign key field, which is the same column in another table. And you can have 3 different kinds of relationships. Generally, though, one-to-one, if there's, if I've got a relationship between a person and something, and it's one-to-one, and then for another person, I got another something, generally that's an attribute in a column. Generally, you wouldn't have another table. You would have that as an attribute in their table. One-to-many is one record, like say your student table, can relate to many records in another table, like maybe maybe your job wants to track how many cars you might have because you're coming into the company parking lot. So you can have one employee and they can have multiple automobiles over in the employee auto table. And then there's a many-to-many relationship. Many records in one table can relate to many records in another table. And that's where you always have to break it out so that you have a way to track the relationship between like the many assignments and many students. And we'll get into that a little bit more. Anytime you are doing relational database design and you have a many-to-many relationship between things, you're going to need a table to break that relationship out. Okay, so relationships. This is where we're starting to get into the notion of an entity relationship diagram, and they call it an entity relationship diagram because each thing that demands its own table, like employee, is an entity. So an employee is an entity. So for this one, we've got an item table. An item is an entity. We've got a price or maybe a tax table here. So each price and its tax rate is an entity. So what we've got here is the notion of one-to-many. So each each item is referred to back here in this by the dotted blue line. It's in there many times. Each polo can be in the item and color database multiple times, but each t-shirt color combination is only in the item table one time. So I've got better examples of this in an actual entity relationship diagram, but this is where you're starting to see something in one table pointing to another and designating the relationship. Now, here I wanted to highlight the many-to-many relationship. So student and ID and assignment ID. There's a many-to-many relationship, right? There's many assignments and there's many students. And you need some way to break out that many-to-many relationship. So the table on the right, like we've been talking about, is created to manage that many-to-many relationship. But within it, you will only have one assignment for each student ID. And that allows you to track what each student did on each individual assignment. Everybody tracking with that?
Yes.
Okay. So thank you, Dr. Hernandez from the University of Kansas. Okay, so that's the, like I said, that's the database design fundamentals without even talking about a certain type of database or opening up any piece of software. All right, what time we got? 11:08. So we've been at it about a half an hour. Let me stop sharing that, and I'm going to go into the next one. And I think I'm going to be out of breath. I have emailed you all credentials for Workbench, so we'll go over that. Nope, not that one. Getting started with SQL. Make sure I got the right one here. Yeah, so you even got the right IP address in the connection instructions. Okay. Okay, everybody getting that PowerPoint?
Yes, I can see it.
Okay, cool. All right. What are we looking at? SQL and why SQL and why MySQL, particularly, because it's free. Free is good. And a lot of companies are sick of paying for Oracle or Microsoft. So they've made the move. And we're actually using MariaDB, which is the like the founder of MySQL didn't like the way it was going. So he branched the open source code for MySQL and made MariaDB. Not sure if you guys heard that little tidbit. So we'll go over single table queries, joining data together in multiple table queries, inner, outer, and self joins, parent-child relationships. We'll learn how to use a subquery, which is just another way to provide a criteria in your where clause, and some of the built-in calculations and single row functions and group functions and whatnot. So basic table queries. That's what we'll be going over for the next couple of weeks. Okay, so why SQL? Because it's cool. So for the purposes of a data analytics class, you got to have data to work on, and most business systems have an underlying foundation of a relational database management system. There somewhere under the hood, there'll be Oracle or MySQL or SQL Server. So if you're going to be grabbing data out of there to work on, you got to know some SQL. And generally speaking, you need to be able to access a database to do analytics. Not always. Sometimes it's placed out there for you. Sometimes a data engineer will take your requirements and provide the worksheets that you need to use. But most of you, I believe, are working in SQL directly. I know Seth is. I know Cameron and Dexter are. Is anybody not using SQL at all or unsure? Kevin, did you tell me you've got direct SQL access to the stuff going on in Intellix?
Only for a part of it. They have like a program called AX. It's like the asset control something. And I used SQL to import a bunch of their data whenever like clients switch over. But like for regular Intellix, they don't use or we don't have access to SQL.
Okay. So when you're running that query, is it basically the same query that you run every time, or are you having to actually, to do problem solving and writing new SQL scripts every time?
Sometimes we have to write new ones depending on how complete the info is that they give us. We have to like fill in any gaps and make sure they're all like relating to each other correctly. But most of the time it's just the simple imports.
Okay. And Alyssa and Jeanette, welcome to your fourth whole day on the job that they've given you. You guys, any idea of what level you'll be working with SQL?
I don't think we've been talking about it as yet.
Just yet. Yeah. Well, okay. I mean, this is, I always look at it as tools in the toolbox. This is a critical thing to have in your toolbox as an analyst or just generally anybody working in IT. So we're going to cover it. All right. So how do we use SQL? Most of the time, it's pulling like a CSV, I am used to pulling multiple columns. So you can select multiple columns across. Maybe you can sort the data a little bit, sort it or filter it in the query so that you don't have to do so much work in your analytical software. But SQL, SQL's character based. It doesn't draw pretty pictures. You can't really aggregate like you can in Excel. There's just a lot of things you can't do in SQL, but it makes a great baseline for pulling tabular data out like CSV files or XLS files or whatever. So we'll use it mostly for that. But you can also answer questions in SQL. If somebody asks you, hey, who's the top salesman in the third quarter for this district who sold at least 3 properties or whatever. I mean, you can program all of that into SQL if you want to, and have that answer, bam, right there. Or you can query all the data out and then resolve that business question in Python or Excel or whatever the case may be. But like I said, some analysts manage the data in databases. But sometimes you've got a DBA working for you. Sometimes the database administrator is kind of higher up the food chain from the analyst. So it all depends on how your team builds the people or decides, the roles and responsibilities within your data analytics program. So that's why we're studying SQL. And of course, relational database management system is the software that implements the things that we talked about previously, the rows and the columns and the tables and other kinds of objects. Oracle, this is probably 3 years old last time I checked. Oracle was the number one. MySQL was number 2, and MariaDB gets kind of lumped in as a subtype of MySQL. SQL Server's Microsoft's, and then way down the line you got I think it's IBM DB2, which is ancient legacy stuff, and you still see Access. Access is still part of Office 365, Office 2019, whatever. And Access is a good little individual relational database management system, but it's just not really set up for any kind of major teamwork. I mean, you can share data in Access, but I don't see anybody using it like for a web application or anything like that. And I say 2 other types here, but I need to add a bullet to that really, because there's one coming on strongly. So we got object-oriented databases that are, I don't know of any implementations of that, and it's you'll see on on the internet, writers are saying that was an idea, but it's merging with relational. But then you've got a NoSQL database, which is kind of cool because it will read in tagged data like XML or JSON, where you've got the data has a label next to the value. It's not just the data like a CSV file. It will read that stuff in, and those files, XML and JSON files, can become pretty complex with hierarchical relationships and whatnot. You read that into something like MongoDB, and it creates this queryable database for you based on the tags. And so but it will also do tables and rows. It'll do both, but you can't read XML directly into something like MySQL, and it won't know what to do with it as easily as a NoSQL database does. But then there's a third kind here that I'm becoming really interested in, called a graph database. And a graph database stores data where the way the way the entities are related to each other is more important than really the attributes. And that is like finding relationships like in a social media network where such and such is a friend of this person or a member of a certain group. And then you can, there's all kinds of national intelligence implications, because this person was a student with this person, and this person was the instructor of someone else. And you start to build all of these complex relationships, and you can start to see who knows who, kind of in very interesting ways, kind of like a 6 degrees of Kevin Bacon, but on steroids. So yeah, there's other types of databases, but tried and true underlying pretty much every web application you've ever used and every information system support system that you've ever used is a relational database. So we have a MariaDB that we'll be working with using MySQL Workbench. If you don't have it installed, we haven't configured it yet, but if you have not been able to download it and install it, please shoot me an email. I'm going forward assuming everybody has it. If you do not have it, let me know. We can work on. So, but I use it for everything for the next 2 weeks. So you kind of got to have it to follow along. Okay, so connecting. I guess I'll just do this in real time here so that we can see how this works. But just while I got the PowerPoint up here, I'm gonna click on the plus, and these instructions are loaded to your classroom in case you need to refer back to them. It's in the SQL module on Canvas. You'll get a connection window like this. I have emailed you credentials, which you'll plug in. All you need is the IP address, which is still accurate, 100.26.226.59. It defaults to port 3306. You shouldn't have to worry about that. If you type in anything in the default schema, type in Northwoods, all lowercase, and then you press test connection. You'll get a warning, but don't worry about it. It'll work fine. And I sent everybody sees everybody else's username and password. You've only got read access to this database, so there's not really any security issue. I think in the future I'll just start using the same username and password, because you can't really do anything, and I don't check which user did what, so it's really kind of pointless. So anyway, let me bring that up, stop sharing that, and share my screen. Share the whole screen. I don't have it up right now. So when you download Workbench, you'll get a start menu shortcut under MySQL. No, I don't think it is. I think I had the database installed. Nope, yep, there it is, MySQL Workbench. I have dragged it down. I never go to my start menu. I've dragged it down to my taskbar. But there is MySQL Workbench 8.0. So you click on that. It is an application. I call it an IDE. I think that's a fair classification, integrated development environment. What it lets you do is work with SQL. So in this case, I have multiple connections here that I've created clicking on the plus sign right here. That's how you create a new connection. And I have, if you have multiple connections and you click on the wrench, you get a list of those connections. So over here, so I'll close that. So let me bring up For example, Christopher's connection here. And it's asking for the password because I have not stored the password in my vault. So real quick, I got to go over and get his password. Arg. Go to my Gmail, go to my sent items. And yeah, my buddy puts sent items. Nope. Not that one. I just sent it. There we go. Connection information. Okay, so for example, I will cut and paste Chris's credentials into the password. And if I say save in vault, it won't ask me again. So I would recommend you guys do that since the security risk is minimal here. And that way it's kind of like, you know, Chrome or whatever stores passwords for websites. All right, so he's in. So this is Chris's login, not mine. So let's go back to, so that's how you guys will connect. Let me go back, exit out of close connection tab. I want to say if we start a new connection, we get to see Lewis. This is a new connection. And we click store in vault. That's where at the time that you create your connection, you can store the password in a vault. You can say, okay. And then if you want to test the connection, instead of actually connecting, you click test connection. What did I do? Bad host name. 100.26.226.59. Is that right? 100.26.226.59.
Yeah, that's right.
That's right. All right. And I've stored the password and I didn't click test. Doggone it. Anyway, you can test the connection or you can go ahead and connect. I think I went through and tested all of your credentials, so you should be able to get in there. And of course, I didn't give it a good name. So anyway, tester. Test connection. Save it in the vault. There's the warning. Good grief. I'm just trying to show you the warning. So you'll get this connection warning, and it's just a warning because we're using MariaDB in the guts, and it's going, it doesn't look quite right. So don't worry about this. Continue anyway. And it will say, of course, information related to this connection. You've got the host, the post, the host, the port, and the fact that we are connected. Okay, has anybody tried this and failed?
Yeah, I tried, but I can't. It says unable to connect to localhost.
To localhost. Let's see what you got there, buddy. Hang on. Was that Seth? That sounded like Seth.
Yeah.
Share your screen and show me what you're getting.
Can you see it?
Yeah, close that. And edit connection. There we go. 100.26.226.59. Got the right port. Get rid of that default schema. Get rid of Northwoods. I do not see any problem. And you're cutting and pasting the password right out of my email, right? And you clicked on test connection. Are you at a work computer behind your firewall?
Yeah, I'm at work.
Yeah, I didn't see what happened on that one, but that could absolutely be the issue. It may be that your work has port 3306 blocked. So if you could talk to your cyber folks, literally this morning, and tell them what we're doing. Give them the IP. If they need it, you can give them the IP address and the port. They should be able to open that up for your workstation. But go ahead and stop sharing, and I'll check. I thought I checked everybody's Seth, but let me bring up Workbench here and do a new connection, and I will call that Seth test. Am I sharing? I'm not sharing
Oh,
anymore.
sorry.
Share my whole screen. Okay, so I got Seth test up here, and it's 100.26.226.59. Got that memorized. Username is not Ruth. It's STURBYFILL, correct?
Yeah, that looks right.
S Turbyfill. And I won't store the password, but I am going to need to go get it. And I'm copying the same exact thing you are. ESPA8AQ. Whoop, make sure I get the U. Control C. Back. Test connection, and it will ask me. Well, hang on. Why didn't it ask me for the password?
You used hyphens there, right, instead of dots. Is that going to be a problem?
Say that again. Ah,
And
it's dashes instead of dots. How did I do that? 26 dot 226.59. How did those dashes get in there? I didn't type a dash. Anyway, okay, so we got an IP address, host name, port, username. Should be all you need. Got a connection name. Test connection. Password. Control V. Okay. Connection warning. Continue anyway. Successfully made. Yeah, it's your port and protocol, bud. If you can talk to the cyber guys, and I know y'all are taking that real seriously lately, but you're going to need that port and protocol opened up to your workstation. Cool.
yeah, I'll email them today.
Okay. Okay. Hopefully they answer their emails to you. I have trouble getting a hold of folks with email. Where else are we? So we got connected. Anybody else having trouble?
Alyssa and I just don't have MySQL Workbench, so we didn't know where to go to download that.
It's on. Well, let's Google it. Did you Google it?
I just didn't know which one was like the right one to do.
Download MySQL Workbench. dev.mysql.com. Yep, that's the one. And we're up to 8.29. Good grief, what have I got? Help about Workbench. 8.21. I should probably update, but I'm not gonna right now because I know it works. So yeah, there you go. Just Google it and go to the MySQL developer website.
Okay, it has you create an account. Should I do that?
I never.
okay.
Go ahead.
Alyssa just answered my question. She said
Okay.
that you can just say no.
Yeah, say no. Yep. So that's the what you the one you want. Go to the download page, and I assume 64-bit, and it's just like any other download, any other installation. So if you guys would download that and check your connection, because you might have the same problem. It depending on your work, they may have port 3306 disabled as well. And just let me know if you send me an email later this afternoon.
Yeah.
Okay. All right. Cool. Thanks, guys. Okay. I am still screen sharing. All right. So that's how we connect. So a little bit more about SQL before we break for the day. This thing has been around a long time. Structured query language, very high level, very English-like, to tell the database what you're doing, what you want to do. We are going to focus on select, but you can also, this is the primary interface to the database. This is how you create tables and indexes and whatnot. This is how you change a table using the alter keyword. This is how you insert rows. This is how you update data based on certain criteria that looks a whole lot like the criteria you give it when you're selecting it. So there's 30-ish keywords. It's an ANSI standard language. And yeah, Boyce Codd, he's got his own normal form because he's the person that developed it in the 70s. But it was first standardized, I think in 86, and 2016 was the last time I checked here within the last year or two. Every database, relational database that we will work with, uses it, but they also add extensions to add functionality, and you see that a lot in they're called stored procedures, triggers, procedural language SQL sometimes. So there are ways to do things that look a little bit more like a scripting language that's above and beyond what we will learn with SQL queries. But SQL select statements are still the heart and soul of this this thing. So they are similar, but there will be differences, and particularly data types. Like the database that we'll use for the rest of the course, or for the majority of the course, was actually created in Oracle at UCA, and I adapted the create statements to create the database objects, the tables and rows and columns. I adapted them to MySQL, and there were issues. It's mostly in the data type, particularly dates. This is just like I'm always complaining about how twitchy dates can be. So there you go. But generically speaking, I think I mentioned this once before. There are families of functionality that we use within a database. SQL is also, in addition to being a query language, it's also a data definition language that lets you define data, which is, in other words, create tables, columns, and whatnot. And that defines the structure of the database, data definition language. MongoDB also has a data definition language. It's different. It's different than SQL. So depending on, and Node4j is a graph database. It's got its own data definition language. So generically speaking, that's what you call the functionality that allows you to set up the structure of your database. Data manipulation language is what allows you to insert rows, update, delete, and view. And that's what we're going to concentrate on is data manipulation, mostly just viewing. I like all viewing. I think I do one insert statement, just but not even part of the curriculum. Okay. Data types matter in SQL. And there's three main MySQL data type categories: string, numeric, and date and time. And within each of those, there are subtypes. We can have a really long one or a fixed length short, like a 2-digit date code. So there's car and varchar. This matters more when you're creating the database and when you are giving it criteria to select. And we'll work with this as we get into the hands-on stuff next week. You've also got numeric types. Integer and fixed point just means I'm going to use, however many a number of my bits to represent a specific number of decimals. And floating point means it can go either direction. The decimal can be used to represent a really, really, really tiny number if the decimal point's all the way on the left, or a really, really, really big number if it's over on the right. Floating point. And then there's dates. Yeah. And there's date math. We can do days between, days since. You can convert years to months and whatnot. There's all kinds of different date functions in there. We'll go over all that kind of stuff. But just like Python, and just like Excel for that matter, data types matter when you're asking, give me everything where something equals something. The criteria have to be in the right format, or you'll get an error. Okay. So guys, I'm gonna call it a week. Give you back the last hour here. Any questions on where we're going? We'll jump in. No kidding with Workbench. So get it working by Tuesday if you can. And if you can't, put it on a private personal laptop or something if you can, and go that route. That's a workaround some folks have used. Go ahead. I'll shut up now. Questions?
I just had a question. I went to download the SQL and I get this error about needing a C++ package. And I just wanted to show you the error, and then maybe you can tell me like exactly what to download, because I thought I downloaded something, but I still have the error.
I'm having the same problem.
Huh.
Yeah,
Go ahead.
I'm going to go ahead and share. This is the MySQL Workbench requires the Visual C++ 2019 redistribution package. And I've Googled them. There's just so many. So I'm nervous that I'm going to just keep downloading a ton of stuff onto my computer.
Huh. Well.
Yeah, I never ran across that one.
Yeah, me neither. When you're working on a work computer, what I would do, guys, is, do you have an IT department?
Yeah.
Is do a little bit of research on your own. Go to the next page and kind of read on which one do I need. Do some Googling. Which C++ 2019 redistributable package do I need for MySQL Workbench? You know what I mean? Just kind of do some research so that when you go to your IT guys, you can help them help you. But I would defer to I don't know how you do desktop management, or if installing a Visual C++ 2019 redistributable package will screw up other software that you need. You know what I mean? So I can't answer this for you. All I can do is tell you to, take 10 minutes, get as smart as you can, and then go to your IT guys.
Okay. Thank you.
Sure. And again, if you've got your own laptop, it may work better.
Yeah, I do have a personal laptop, so I might try that just to see.
It might.
If that's the easier thing to do.
Yeah. And what I need to do is re-engineer this course so that I'm not using any downloaded products, because I've had trouble with people freaking out because their work didn't want them to download Python because, you can write code now and code's dangerous and can't have that, so And folks have had trouble getting I had one person that never did get my workbench working because their IT department was unable or unwilling to troubleshoot it for them. And I'm telling you, it's the port and protocol. It's blocked at the firewall. But that I was never able to get her IT department to support her. So anyway,
I do have something to ask.
sure, Dexter.
Throughout my apprenticeship, I've been learning a bunch of things, but as I learn, I think it's kind of good that we get to meet other people and that's going through the same thing we're going through as apprentices and internship as well. And I was trying to reach out because in my experience, I have come across a bunch of problems that I didn't know existed when it comes to like working, like certain problems like coding and such like that. And I've been learning a lot, and I was going to start reaching out to people and trying to share the information I learned throughout my process, and also ask some questions to peers. It's
Sure.
kind of hard to like get on Stack Overflow and ask people questions that you don't really know or heard their voice or seen.
Sure. You're welcome to leave me off of it. I mean, a lot of people don't, or you can include me,
Yeah, I'm gonna
but
include you, of course.
but yeah, you can reply all to like I just sent out. There's all 8 of y'all and me are on that email I sent out with the login criteria. So you can use that as like a discussion group, and you're welcome to email everybody. And if y'all don't want to get them, just delete them if it gets to be too much, or let us know. But yeah, I'd love to see more interaction and collaboration within the group. I would love it. Okay. Any other questions or comments? All right. As always, guys, I'm traveling. I'm flying out here in 4 hours, but my email comes to my phone, and you've got my cell phone is in that signature block of that email I sent you with your username and password. Feel free to call or text or email if you have any issues. But yeah, Alyssa and Jeanette, if you could keep me apprised as to how that's going with your IT department, let them know, and you're welcome to, keep Paula and what's your supervisor's name?
Peyton.
Peyton, that's it. Yeah. And actually I emailed Peyton yesterday. If you could ask him to answer my email, that'd be great. Is he in the building with you?
He's going to be. He's not right now. But yeah, I just downloaded the link that we're supposed to from doing some phishing. So I think we will have to reach out to IT.
Cool.
Because it might be like a block and why we can't
Yeah.
get it to work.
And let Peyton know I sent him an email yesterday. Some folks get 5,000 emails a day, and they just can't read every email.
I'm working on it right now. It looks like I'm able to do it. I tried a different download button, and that seemed to be working. So if it works, then I'll help Jeanette get set up.
Awesome. Just keep me posted as to how that's going. All right, guys. Anything else? Well, my weekend starts in a few hours, so I'm going to wish you all a good weekend. I'll see you on Tuesday to write our first SQL queries of the class. Hasta luego.
Have a good weekend.
Bye. See you later.